Assalamu alaikum. I hope you're doing well with your e-learning. Today, inshallah, we will solve some practice questions on inelastic collision, section 3. So the objectives of today's lesson, we will solve practice problems on inelastic collision to determine what we call recoil velocity, given mass, and initial velocity. Now, before we start solving practice questions, let's just refresh our memory a little bit about what do I mean by inelastic collision. What do I mean by inelastic collision? Now here I have the same fit simulation we used last time. This time I'm going to use inelastic collision, and I can make them having the same velocity, both balls having the same velocity. Red one and the other one, which is the green one, the velocity of the red one is 1 meter per second. So its momentum will be mass 1 times 1.5, it will give you 1.5. Now the red ball, it's not moving, so it is velocity 0. Momentum, it sure will be 0. Now remember this value. Before the collision, I have to add the momentums. So the initial momentum or the momentum before, it will be 1.5 plus 0, 1.5. Now, if I let them now collide or hit each other, now look what happened. Both of them, they moved as one body. They stuck together and moved as one body. This is what we call inelastic collision. So inelastic collision, if they're moving after the collision as one object, one mass. How can I calculate the momentum after now? The momentum after, I'm adding both masses together, which means 1.5 plus 1.5 to give you 3, times their velocity, because they're moving with the same velocity. Look here, both of them, they're having the same velocity, which is 0.5, both of them. So 3 times 0.5, they will have 0.75, both of them. 0.75 plus 0.75, it will give you 1.5, which is equal to the initial momentum. So the momentum is always conserved, whether I have elastic, like the collision we studied before, and we will study it in more detail, inshallah, later on, or inelastic collision. Now, where can I find this type of collision in real life? Now, look here, I have actually two train cars. Now both of them, now they're moving. The one on the back now hits the one in the front, and now they're moving at the same body, at the same object. Or I can have a car. You will see this small car, it will hit now, it will collide with a stationary police car. You see, at first they're moving at first as one body. So this is real life situation. Let's start with the same practice problem, and this practice E from your textbook, perfectly inelastic collision. We're going to read as we usual, we read it. We have to draw our table as we studied before, and then fill this table. So I have 1.5 times 10 to the power 4 kilogram rail. Just I need my pen. Okay, railroad car moving at 7 meters per second to the north. So the first object, I have railroad car. I have to specify my object. This is my first object. Collide with and stick. Look at this word, stick. When I see collide with and stick, I know immediately it is inelastic collision to another railroad car of the same mass, which means both of them, they're having the same mass. So when I fill my table, I write M1, 1.5 times 10 to the power 4, before or initial, and final, before or after. Both of them, they're having the same mass. So this one and this one, they're having the same mass, M1 and M2. Okay, before and after. Now, is moving in the same direction at 1.5 meter per second, 1.5 meter per second. What is the velocity? Both of them. This is what actually, the first car moving with 7, so I'll put 7 here. Second car is moving with 1.5, which is this one. After I fill these values, I have to calculate the momentum. Okay, mass times velocity, calculate the momentum, mass times the velocity for both cases. Now let's come to the final. Final velocities always is equal, move, because after they stick together, they will move with the same velocity. So I will call this velocity V. V1 final for the first object will equal V2 final for the first object, and name it V because it's the same velocity. Same velocity. Okay, what is the velocity of the joined car after the collision? Which means I need the value of V. What is V? What is this value? Again, I'm going to use what? The conservation of momentum, which means initial equal final. I look only at the colored values, which means P1 here, the initial for the first car, how much? This number. Plus second car, how much? I put it here. Equals, now go to the final. Final, I don't have actually the value of V. So both of them, I add their masses because they stick together. I add their masses and they will move with the same velocity. So if I add 1.5 times 10 to the power 4 plus 1.5 times 10 to the power 4, it will give you 30,000 times they're moving with the same velocity. Now this is an equation. Now math is not physics anymore. You solve this equation and you find the value of V. And it will give you positive value. It will move at north, the same direction of the railroad car, north. Okay, we'll continue solving the other practice problems, inshallah, in the next video.